Hey, what's up? My name is Chris, and today we're going to talk about how you can not only do inference with, but also build a very simple agent application with the NVIDIA-hosted NIM API for the brand new GPT-OSS models from OpenAI. Both the 20B and 120B are available as their own respective NIM, which you can use through the NVIDIA-hosted NIM API, or you can download, deploy, and start using your local infrastructure today. We're going to focus on the NVIDIA-hosted piece that's available on build.nvidia.com, but we'll include instructions on how you can go ahead and download and deploy each NIM if you want to get started locally. Let's go ahead and move to build.nvidia.com to see how we can find the models and then how we can start using them through our Colab notebooks. Now that we're at build.nvidia.com, we're going to go ahead and want to navigate to the model that we're going to use. In this case, we're going to be using the GPT-oss-20b model from OpenAI. We can go ahead and click on this tile to get started. You'll notice that we have a familiar chat interface where we can ask questions, see the model do inference, including its reasoning traces. What we're going to do, though, is to access the model programmatically, we're going to navigate to the View Code option in the top right here, and then we're going to go ahead and generate our API key. This is what we're going to need when we get started with our Colab notebook. Once we have our API key generated, we're good to move on to the next step. Now that we have the API key from build.nvidia.com, we're ready to head to our Colab notebook where we can get started building. All right, finally we can jump into our notebook and talk about how we can do inference with the Responses API, the Chat Completions API, as well as build a simple web search agent with the OpenAI Agents SDK. Let's jump forward to where we provide our API key as an environment variable. All right, we have our API key, so we can actually set an environment variable to keep track of it for us. Very nice. And then we can install the OpenAI Python SDK so that we can hit the Responses API programmatically. Setting up our client is pretty straightforward. We're going to use the OpenAI client. We're going to include the base URL that points to where our NVIDIA-hosted NIM API lives, as well as providing our API key so that we can hit it without getting any errors. You're also going to see that we're using the Responses API, which is going to be powered by the new Harmony response format for this model. This is actually something that's entirely taken care of by the NVIDIA NIM, so it's not anything you have to concern yourself with. You can use the Responses API just like normal with this model, thanks to the work that the team did on that NIM. All right, and now we're good to just go ahead and hit the Responses API. We can hit this like normal since NVIDIA NIM has already done the work of ensuring that the Responses API is set up and available for us. So we just provide our prompt. We hit the client.responses.create API. You'll notice that we provide the model name here. Our input goes in just as we set the prompt up. And because we're using Responses API, we can actually specify a reasoning effort. In this case, since it's a fairly simple question, we can use low. We've manually reduced the number of max tokens here just because this is a simple response. But the model does, of course, support up to 128,000 tokens. You'll also notice that we're using the recommended generation configurations. We're using streaming equals true, and then just handling that streaming response. When we send this request, you can see that the model is going to go ahead and reason for a little while. You're going to see many reasoning tokens being generated, and then finally it's going to produce a response. This response is correct. We love to see it. Great job, model. Let's move to the next example. Now we're going to try a little bit of a harder question. This is from the Amy 25 dataset, so it's a math question, and we're going to have our model think through and then provide a response in the boxed format. You'll notice that because this is a harder question, we're actually going to use reasoning effort set to high. The handling is the same here, and you'll notice that when we do this inference, we get a lot of reasoning tokens, right? And we do eventually get to the correct answer of 16, but the model does use that reasoning effort to ensure it gets the correct answer. Let's look at how we can actually set up a simple web search agent that's powered by the GPT-oss-20b NIM in the next section of the notebook. All right, so what we need to do in order to build our simple web search agent is grab OpenAI Agents SDK as well as Tvili Python, which is going to power our web search. We can go ahead and also set our Tvili API key instructions in the notebook on how to get that. And then we're going to set up our async client. So the same process that we saw before, except this time we're using the async client. We need to set up a tool in order to enable our agent to have access to web search, and we can do that in the following manner. We set up a Tvili client using our Tvili API key, and then we use the @function tool decorator from the Agents SDK, and we wrap our async search web function with it. We provide instructions on how the model should use this and what parameters are for. And then we return a new line joined string of the different responses as well as the title of those responses from Tavili. Next, we're going to use the OpenAI chat completions model as our provider. The reason we're doing this is because the NVIDIA-hosted NIM API doesn't support tool calling with the responses format at this time, and so we need to use the OpenAI chat completions model in order to get that tool calling. Setting it up is as easy as this. The rest of this is just exactly from the OpenAI agents SDK. More instructions are available on that through their documentation, but the idea is that we're going to have an assistant. It's going to be helpful and respond in a format that is useful for enterprise executives, and it's going to have access to our search web tool that we defined above. We need to do a little bit of bookkeeping here, so we're actually going to set tracing to disabled. What this does is make sure that we're not trying to call out to OpenAI with our traces. And then finally, we can run our agent. We use the runner.run with our agent on this query. Briefly describe the enterprise benefits of NVIDIA NIM, 200 words or less. We print the final output, and you can see we get this markdown formatted response that includes all of the benefits to enterprises for using NIM. That's it for the video today. I can't wait to see what people build with the GPT-oss-20b and 120b NIM. Again, if you want to get started, it's as easy as heading to build.nvidia.com and just accessing the API through the NVIDIA-hosted NIM API, or you can download and deploy each NIM and start building on your local infrastructure today. Thanks so much for your time, and I hope you have an excellent rest of your day.